Hi, I wanted to take a look at those micro USB rechargeable AAA cells that I got from Tiger. At first I was really excited because it was about $5 or around €4. So it was exciting at the first, but then I noticed this. These are Ni-MH rechargeable cells. So this means that what they actually did, they you probably can see over here that they put a tiny Ni-MH nickel metal hydride cell inside here, and then a charging part with a port. Let me open this and let us take a look. So let me cut through this, because what I can tell you that normally rechargeables cost about $20, something about that, for two of them. So that was a bargain, and it explains why it was a bargain. At least there is a nice rubber for the cable, so presumably that's the best part. These, it does say that each is 350 milliamp hour. So not a lot. Oh, it seems that it all fits fine. Let me start with measuring these, how they are coming out of the box. Well, these are, by all intents and purposes, it seems that these are charged. Yeah, 1, 2, 7. And I cannot really start charging them right now because, well, they have memory effect. That's why we don't use those nickel metal hydrides anymore in most devices. What happens with nickel metal hydride when they are being charged, for example, at 50%, they will remember that's the memory effect, that lower band, so they will almost cut off at the 50%. I mean, that's the generalization, but overall it's kind of hard to get out of this memory effect. You usually have to discharge them at very low current and then charge them at, if I remember correctly, 1/10 of their capacity. So in this instance they should be charged at 35 milliamp during 10 hours. I don't need to really wait to discharge them. I can try that, but let me try and peel off a little bit of that foil. I will replace that later on with sticky tape. Okay, let's take a peek inside, because from what I saw there is, yeah, that's a standard cell on the inside, and there is a separate tab, and to the minus. I will have to glue it back together because some devices don't really have a proper installation, and it may short out. That's the minus, and it's probably pushed on the top of the cell where that could be the plus of the cell. It seems that there is a tiny board inside. Yeah, and I think I can get inside. Let's take a look here. What is really good with nickel metal hydrides, you can actually they stand to abuse as opposed to lithium ion rechargeable cells. So if you short them out for a while or something like that, they are actually much more resilient to let's say elements and messing around with them. Let me take a look. I don't really want to rip anything here, so I was kind of hoping that I will be able to, yeah, just disassemble this. I think it's glued down. Okay, and this is removed, and this is our tiny little cell, so it just uses this tension to keep it on a spring. Let me start measuring that stuff. This is a minus, this is a plus. Yeah, that's exactly it. So it means that this is connected together, probably. And let's see, this tab is, yeah, connected directly to the ground of the power supply. There's this tiny little chip. Okay, here I have a power bank. It's not connected, so it won't charge at all. What I'm curious about is the current voltage at the output. So that's the minus. Let's take a look at the plus side. Okay, let me try that again. So that's exactly 1.4 volts, which is really good. Probably it would drop if I use anything as a load, but that's actually pretty good. You could reuse this little chip to create for yourself a tiny charging circuitry for a standard rechargeable nickel metal hydride cells. Okay, so allow me to explain my setup here. Here's minus, here's plus, and here I have the current that's going through the circuit, I mean on the output of the charging circuitry, and here's the voltage of the circuitry. So I'm putting plus here, minus here, so it drops a little bit, but at the same time current rises and it's 14 milliamps, which is, well, it's just fine. Let me try with another one here. Yeah, these are broken batteries up to 50 milliamps, so yeah, it rises very quickly because these are very warm batteries. Also have here a tiny circuit that should rise the output voltage to 5 volts. It currently takes only 6 milli. Let's run this. Yeah, see, 5 volts at the output, so this is 1.35, 40 milliamps. Let's take a look at the, oh, sorry, I think I lost connection here to one of the probes. Yeah, here we go. 135 and 40 milliamps at the output. If I try and connect something here, try it out, it should cut out completely, but let's see. 104. Yeah, it's getting quite warm, so it started to drop significantly. As you can see here, it changed the LED color to red because of the current it currently takes. So if I disconnect it, it's blue again. It's only in standby, let's say, and it's now connected. So it can reach up to, yeah, it's on the, let's say on the edge, it can reach up to 104 milliamps. So that's quite a current to charge a tiny cell. So it would work, in my opinion, even with a nickel metal hydride AAAs. That's quite interesting circuitry. The cells aren't really, you know, impressive, let's say. But what I really like about this is the tiny charging circuitry itself, because you can actually reuse this and use it as a charging circuitry with a microUSB. So connect several cells, nickel metal hydride, proper big cells, and not exactly use this. Just reuse it for the circuitry. So in my opinion, for $5, this tiny cell, it isn't doing much. But if you want to reuse the contents of this to some other project, yeah, that could be quite a good idea. So that's all what I have for you guys today. Thank you so much for watching. See you guys next time.